Welcome to this tutorial. Today we want to look at ordinary differential equations. In short, we call them ODE. We want to know first, what is ODE? Where does it come from? Before we start this tutorial, kindly subscribe so that in every time we post a new video or a new tutorial, you get to be notified. Okay, welcome. Let's start. Let us start. What is ODE? That's a big question. So what is ODE? First, what you need to note is that ordinary differential equation, or ODE, is a differential equation. So it's a form or it's a type of a differential equation. So a differential equation is an equation that involves derivatives or differentials. So it involves two things, derivatives or differentials. Same thing, of course. So for example, if you look at this example given here, that we have a function of fx, y equal to fx, this kind of function. If you get a dy dx, you get the derivative of a function of x, which you are going to see that dy dx is actually what we call a derivative. Then if we multiply both sides by dx, both sides, we get dy equal to the derivative of x, f, first derivative, dx, which is called now a differential of y, So and dy is a differential of y, dy dx is a derivative. I think you can get that difference clearly. Dy dx is a derivative, dy is a differential of y, Okay, so ODE is a differential equation in which only ordinary derivatives appear. The derivatives are taken with respect to a single independent variable. That's a very key thing. Single independent variable. So a single independent variable gives the pure definition of ODE, because all derivatives are taken in respect to a single independent. If you get such kind of a differential equation, you automatically qualify that one to be an ordinary differential equation. The independent variables are actually function of single independent variables. So if the differential equation is not ordinary, you find that it's not ordinary, then it is the opposite, which is partial differential equation. And in partial differential equations, it involves two or more independent variables. If we have single, that's one, that is ordinary differential equation. If you have two or more, that becomes partial differential equations. Our interest in this case is ordinary differential equations, or these. Okay, check out. Let's look at this. Classify into ordinary differential equations or partial differential equation. We have this equation here for here. If you look at this one we have derivatives in respect to one variable, which is x in this case. So this has the A has only one independent variable, which is x. If you go to B, you'll find that it has derivatives which are dependent into two, x and y. And in this case, this means that in B, x and y are two independent variables. Then in C, they are all in respect to x, and therefore C has only one independent variable, which is x. So without even doing, think of it. Among the three, which one is ODE and which one is PDE? Kindly check out. Put it in your comment down there, and before we see whether we have gotten. Remember what you have said. We have said a ODE is a differential equation which derivatives are taken with respect to single independent variable, and a PDE, partial differential equation, is a differential equation which derivatives are taken based on two or more independent variables. So this, with that, we can check the solution. You'll find that A and C are ODE, while B is a good example of PDE. Yes. So kindly remember to subscribe. Until next time we meet.